So I'd like to tell a story about scientific wellness, and that's my name, I guess, for radical wellness. It's quantitative, and it's very different from how we typically think about wellness. And I would say the story in many ways started in 2000 when I started the Institute for Systems Biology, and this was the first Institute for Systems Biology, which is a kind of a global, holistic approach to thinking about biology and about disease. And at that time, the systems approach to disease led to something we call systems medicine. And I would say systems thinking gave systems medicine four important things. One, it created the concept of really dense phenotyping. The idea, if you go to a doctor and you get 20 measurements and or observations, it doesn't begin to touch the complexity of the human with regard to wellness or with regard to disease. I would say, two, it fostered the idea that we could explain a lot of disease by hierarchical networks, the information byways, which, when disease perturb, lead to disease. And being able to define the disease-perturbed networks gave us insights into mechanisms and biomarkers and things like that. I would say, number three, it really pushed the idea of technologies and systems-driven strategies. And I'll talk about a few of those. And then finally, the whole foundation, of course, is computational and analytic platforms that can deal with all the information. And I'll remind you that systems biology, and this is something many people don't understand, in the end is biology. And correlations aren't mechanisms. Systems biology operates by perturbation of the system to test hypotheses. What also emerged from kind of these systems thinking about healthcare was the conviction it should be predictive and preventive and personalized and participatory, and we called that P4 healthcare. And by the time of 2014 or so, it was clear that this P4 healthcare really reflected the convergence of systems biology, of systems medicine, of digital health, of something we'll call scientific wellness, which I'll define in just a moment. And I think one thing that was really important was big data and its analytics, and even social networks. And of course, if we take P4 as we understand it now, I would say it differs from contemporary medicine in really striking ways. One, it's proactive. Two, it focuses on the individual, not populations. Three, it has a major thrust toward understanding wellness as well as disease. Four, it is centered in this dense phenotyping, what we call personal dense dynamic data clouds. I'll define those in just a second. And I think the fifth point is the argument that the clinical trials as we do them are utterly fatally flawed, and they should totally be replaced by P4 approaches to trials. So what do we do now? We'll take 20,000 individuals and give half a placebo, half a cancer drug. We'll abstract the data. And of course, the fundamental assumption of that clinical trial is the individual units are identical to one another. Absolutely not true. They're different genetically, they're different environmentally. So what P4 trials do is to take 20,000 individuals, each with their data cloud, and then cluster them according to the questions that you're really interested in, like, can you identify biomarkers that distinguish responders from non-responders? And if you look at the 10 top drugs in the US today, the responders range from 1 in 4 to 1 in 25. So if you could start a clinical trial out with all responders, as Genentech did for Herceptin, you'd get the FDA with 46 patients to approve at a 96% success rate, that kind of trial. So trials are really going to fundamentally change. And of course, the essence of P4 medicine was it's all about wellness on the one side and disease on the other side. And my argument is quantitative wellness, scientific wellness, is going to create a whole new wellness industry in the future that in a 10 to 15 year period will have a market cap that far exceeds that of the old disease industry. And of course, the really intriguing question, and I talked to the top executives at Merck recently about this, is what is pharma going to do if wellness is going to be the major healthcare vector in the future? And that's a really interesting challenge. Wellness is important because you can do a calculation that if you take the kids that are born in this calendar year, you can estimate that half of them will live to be 100. And the question is, what is the quality of their life for the last 35 years or so? And I'll say classic 20th century medicine focused only on disease is never, ever going to be able to touch that problem. You really have to deal with wellness and as we heard today, aging to really attack that problem effectively. So in 2014, Nathan Price and I persuaded 108 of our friends to subject themselves to this dense phenotyping, where we did the complete genome sequence. Every 3 months, we did blood draws that gave us clinical chemistries, metabolites, and proteins, roughly 1,200 analytes there. We did the gut microbiome every 3 years to quantify species, and we did Fitbit and other quantized self-measurements. And integrating this data led to a whole series of actionable possibilities, which for each individual were totally unique in their combinations. And of course, we brought the actionable possibilities to the 108 pioneers with a wellness coach who was magnificent at psychology, figuring out what individuals wanted for their healthcare objectives, and explaining the actionable possibilities. And I would say overall, the 9-month experiment turned out to be incredibly successful, both improving wellness for most of the pioneers and generating data that gave us a whole new view of biology and disease. And I'll talk about that in just a moment. I will say we could follow for a period of a year or so classic indicators like prediabetes, like cardiovascular, like nutrition, like inflammation, and typically we could get 20% improvement for the out-of-line individuals in these particular areas. And so there was so much enthusiasm from these people that in mid-2015, we started the company called Aerovale, which was to bring scientific wellness to individual consumers and so forth. And I'll say, you heard a little bit about Aerovale this morning. I'll say 2 important things from my point of view. One, they have now almost 4,000 individuals with the dense dynamic personalized data clouds, some of them for almost 4 years in duration. And what we're beginning to see is wellness to disease transitions for all major chronic diseases. And I'm going to return to why that's important in just a moment. The Institute has a partnership with Aerovale to actually co-analyze the data together, and this has been incredibly successful. And in fact, I can talk a little bit about that now. From these data, from the 100 pioneers plus the Aerovale data, I would say there are 3 major observations we've made. One, we have the ability to correlate individual data types from each of the 6 major data classes with data types in any of the other 5 classes. And we can do static correlations at one point in time, or we can do dynamical correlations across time. And it turns out in doing both of those, we end up with almost 4,000 statistical correlations, and the two sets almost don't overlap. They're really looking at very different things. But the static correlations are really fascinating because we can break those correlations down into more than 70 communities that correlate with biomarkers, with disease, with biochemistry, with disease mechanisms, and so forth. And these are relationships of analytes and so forth that open up the possibility of seeing interrelationships never seen before and beginning for certain types of biology or diagnostics to identify new kinds of biomarkers or new possible drug targets. And we've checked a number of these against the literature, and indeed, we find 5% of them are actually all in clinical trials at various pharma. The second really fascinating observation are these wellness to disease transitions. Because what happens, for example, one of the first we observed was a 57-year-old woman who in January of 2017 was diagnosed with stage 4 pancreatic cancer. We had 4 prior blood draws to that diagnosis. So we could go back and look at the 1,200 or so analytes for each of those blood draws. And we could ask, does that woman have outlier analytes that stand out away from the, at that time, 2,000 individuals and their own analytes? And we did this one at a time for 1,200 analytes, and we found one incredible protein that's part of the Notch receptor class, specifically found in the pancreas, that offers itself as a candidate biomarker and or even a possible drug target. And of course, you have to do a perturbation experiment to test that, and those kind of things are being done. The important thing is we've seen wellness to disease transitions for most major chronic diseases, and that's a point I'll return to in just a second. With regard to the conversation that we just had, we're able, for example, to take the 4,000 individuals and divide them into decades of 20 to 30, 30 to 40, 40 to 50, 50 to 60, and we can ask about the variance of expressed clinical chemistries or metabolites or proteins. And what we find is there's an enormous increase in variance as you age. And I'm not going to go into the details, but what I can say is you can use that to actually look at a single individual, say in their 80s, and derive a biological age for them as opposed to a chronological age. So, for example, my biological age is about 15 years younger than my chronologic age. And of course, that's good. But what's interesting about this metric is I'm beginning to do N of 1 experiments to see if I can expand the 15 years to 20 years and what it's going to take to make these changes. So for the first time, we have a quantitative index, the ratio of biological to chronologic age, which can serve as a metric. So a really important point that I want to make is in thinking about chronic diseases, and we studied prion-induced neurodegeneration almost 10 years ago, and what we were able to demonstrate beautifully in mice with activated prions to trigger the disease. 1, the disease lasted 22 weeks. 2, as the disease progressed, the number of disease-perturbed networks expanded strikingly. And 3, we could see both from brain transcriptomes and the blood changes that preceded by 13 weeks the first clinical signs of disease in the mice. So what I'm saying for humans is we want to do exactly the same thing. We want to be able to find that initial transition point, and with the data clouds, create the biomarkers, as I've suggested here, and use some of these systems approaches to generate therapies to reverse the disease at the earliest stage before it ever manifests itself as phenotype. And I'll tell you, the first study we're doing is a study on Alzheimer's, and I think we have a superb chance within 3 to 5 years of being able, one, to get the earliest diagnostic marker for Alzheimer's, and two, reverse 70 or 80% of the individuals back to normal before they ever go into an irreversible disease phenotype. And of course, Alzheimer's, somebody said it was $250 billion cost to the healthcare system. That's the cost of what you do for the patient. The cost to the caretakers is another $250 billion. So it's a $500 billion cost. Suppose in 5 years, we can get rid of 80% of those. Talk about the savings that will come to the healthcare system. And the really interesting question is, who's going to get those savings? I'd like to see payers be the providers. Providers be the payers. So they incur the savings rather than insurance companies who are really skeptical about this kind of thinking. What happened to me that was really transformational in late 2015 was the CEO, Rod Hochman of Providence St. Joseph's, came to me and said, I'd like ISB to become a research arm and you are chief science officer. And I'd been searching for ways to bring P4 medicine into the healthcare system. And I'll tell you, I went to 6 really good academic medical centers, and including Hopkins, which was my alma mater, and the response I got from all of them was always the same. There were incredibly powerful silos that said, nope, we're not interested in this. I think primarily because they saw it as competition for resources or prestige or whatever, but a large community hospital system thought very, very differently. And in the 2+ years we've been there, it really has been transformational. So let me say, Providence is headquartered in Seattle. It is a big healthcare system, $20.6 billion a year operation, 50 hospitals, 5 million patients a year, 30 million electronic medical records. So they have really everything we need to do clinical trials anchored in this deep phenotyping that we've talked about. And we have 2 such underway. One is on scientific wellness. We're doing 1,000 employees for Providence into Aerofail for a 3-year program against 1,000 random employees treated as they were before. And the objective, one, is proving we've increased significantly wellness, and we already have good statistics on that. But 2, making economic measurements of the savings that are going to come. And I think those are going to be equally striking. The second clinical trial we've gotten started on are 2 small Alzheimer's clinical trials. One that uses a striking new multimodal individual adaptive therapy pioneered by Dale Bredesen at UCLA. And he's had incredible success in observational studies showing that if you get early Alzheimer's, you can reverse up to 80% of the individuals back to normal. And we're hoping that's where it's going to go. So what I would say is, as we look at the healthcare system today, almost everybody is practicing 20th century medicine with a focus on disease and curing it. And I'm arguing it's 21st century medicine with focus on wellness as well as disease, and a real focus on wellness to disease transitions for the reversal, eventually, of most chronic diseases that's really going to make a difference in the future. So I think what 21st century medicine is going to do is, one, really optimize individual wellness. Two, it's going to make it preventive and predictive by being able to tag the earliest transition point and reverse it. That really is the preventive medicine of the 21st century. And number three, I think the cost savings are really going to be striking. Thank you.